So we have, so far we did one input and one output, right? Y equal to fx. But we have sometimes functions with two variables, x comma y. So this could be height of a mountain. It is x coordinate, y coordinate. We have a height. So how do I visualize this? So of course, you can do a 3D figure. Okay. Now, in fact, you can do real 3D figure with goggles. Okay. Unfortunately, we can't do that on a 2D plot, but we do a projection. Okay. So in fact, the surface plot is like a projection. But you are aware of that we can also do a contour plot. So we make curves with same value of z. So there are so all the points which are same value of z, we join them. It's called contour plot and density plot. So for different height, I choose different color. Okay, so that's density. So let's illustrate. Let's show them and how to do it with Python. So my function is x squared plus y squared by 2. Okay, this is my function. Now I create these two arrays, minus 10 to 10, x and y. So they are ranging from minus 10 to 10 with 100 points. Now this is the important line, this one. xv comma yv is np.meshGrid. So I create a mesh. So the number of points in the mesh is 100 by 100. So the 10 to 4 points. For every point there are two values, xv and yv. xv is the x coordinate. Okay, so mesh grid function creates that coordinate. Okay? So xv has a 10 power 4 elements, and at every point it gives you the x coordinate of that point. Yv is similarly the y coordinate at that point. Okay, so in fact you can plot them, you can print them, and you can see what they are. You can just play around with z equal to x squared plus y squared by 2. Now I want a contour plot, so this is the function, most important function. Curves equal to ax dot contour xv yv. This is the mesh grid, and z, that function z, and I want 6 contours. Okay, so 6 contours, and I can label them. So that's why the curves is argument. This whatever is coming out of the contour, it comes as argument for labels. So contour labels, and the size of the, thickness of the size is of the lines is 1, and font size is 10. Okay. Let's see how it looks. So this is a result of that function. So we have these contours, and they are different colors. Huh? So the blue color is blue is innermost with the lowest value of contour, and when you go outward, it becomes yellow and yellow. Okay, so this color convention is used by this function, and so it's also there are numbers written 15, 30, 45, 60, all that. Okay, so this is straightforward, and you can use it for your you can use it for your other courses or projects. Now density plot is very similar. I need to create the mesh, and then you call the function image show, im show. Okay, so the z and minimum to maximum. Okay, so we min, we max. So I advise you to keep these files. I'm going to send you these files. Okay, I'll share these files, and use them. You can use them for your exam, quiz. You're free to use it. Not quiz, lab. So C2 is P color mesh. So there are two ways to do density plot, either by image show or P color mesh. They are different, slightly different output, different algorithm, but both of them give you density plot. So these are coming from these two functions. So here, this is called color bar. So 0 is the lowest. So y equal to, remember, z equal to x squared plus y squared by 2. So lowest value is 0 at the origin, and then this function goes like that. It's a paraboloid. So when you go up, right now the function is increasing, but this is done automatically by the code by Python. So the maximum value in fact is 1. So it's going to choose. So you can choose your color scheme I don't have it here, but in the code which I'm going to share with you, you can choose this color scheme. Okay, there are many color schemes, like the gray color scheme, or there's a, you could have red to white, red to black, things like that. Okay, so I chosen one of the color schemes. So it starts, lowest value is blue and the highest value is yellow. Okay, so you can see that yellow is at the corners, and image show looks better here compared to p color mesh. These are different schemes. I mean, I really don't know inside what happens, but anyway, they are doing roughly the job. So mesh is somewhat visible at the background. Now we can do surface plot. So there are this called wireframe and surface. So there are again two functions. Plot surface is one function, and wireframe is another function. Now, so there is a library called Axis 3D. Okay, I didn't put it here. So is there in the notes? I will find all these things detailed in the notes. So we have Axis 3D. So Axis 3D. So you have to use this one. Okay, projection equal to 3D. So this is basically a 3D plot. Okay? It's a projection of a 3D plot. Sorry, projection of 3D object. Okay, so there are things like color. The color scheme is M here. Okay, this is a color scheme. Now the plot looks like this. So this surface plot. Okay, you can see. So this is not same as x squared plus y squared by 2. I'm sorry. This is exponential minus x squared plus y squared by 2. So it's a Gaussian profile like that. Okay. Now surface plot is continuous, but wireframe is not continuous. These are basically you make the 3D object with wires. Okay. So it's a pretty straightforward. You can get this nice pictures with Python. Now we can do vector plot. Now this is for my 3D plot, but for 2D plot I'm not using the same vector. It is minus x cube plus and minus y cube. Okay. Let's look at the syntax. This is a function. ML toolkits dot mplot 3D import axis 3D. So you need to import this. So this line must be there in your code. Otherwise, the 3D thing will not work. Okay. Now we create the mesh. So this is a very important part. Okay, mesh grid. Now given this mesh grid, XV and YV. Okay, the mesh grid. So query means arrow. Okay, query is a name for it's a synonym with arrow. So every arrow has two components, x component and y component. In 2D, there are two components. So the x component is minus x cube and y component is minus y cube. So every point I create this arrow. Okay, with two components. So this is a vector plot, and that is for 2D. For 3D, I create 3D arrows. Okay. Now this again link space for mesh grid. So all of them minus L to plus L. So L is defined. I don't remember what is there. No. So L is box size. Well, box size by 2 minus L to plus L, and we create the mesh grid. It's a 3D mesh. Now it's not 2D mesh, 3D mesh. And now these arrows are three components: xv, minus yv, minus zv. So it's a vector minus x or minus r, so minus vector. Now they look like this. This is a 2D vector. It is minus x cube minus y cube. Okay. You can convince yourself that this is indeed the case. So this has both the components equal, but going inward, and this is only the x component. Well, roughly x component. This is some y component. Okay, and the magnitude increases when you go away. Now this looks, of course, not very clear, but this is minus vector r. Okay. Anyway, this is 3D, so it's a projection, and Python is trying to do as good as possible. I would say that you should make a cut section, and you can figure out what that is. So in your EM course, especially, you can make this for, like, I would advise you to make these plots for a dipole. or quadrupole. So you can make these plots, and that's the best way to learn. As soon as you get something, you plot and verify that. By the way, many of the plots in the books are not correct. They are basically crude sketches, and once you plot them, then you realize what is the actual vector field or scalar field.